Hi everyone, welcome to my channel Tech with Ayush. Let's get started with the LeetCode daily question. So today's question is finding the kth smallest element in a sorted matrix. Let's understand the question a little better way. So we are given a two-dimensional sorted matrix, a two-dimensional matrix where we have to find the kth smallest element. A quick interview tip. Whenever you are need to find kth smallest element, kth largest element, kth element from start and something like that, think of two techniques. These two techniques will basically tend to take you towards a solution: sorting or heaps. Okay, let's understand the question a little more better way. So you are given an array which is sorted left to right, top to bottom, and we need to find the kth smallest element. For the simplicity, let's assume the kth value is 5, and we need to find the fifth smallest element in this array. We can see that it will be 9. Let's think of a solution, right? How you can actually find the kth smallest element. So if this is given to you as a single one-dimensional matrix, how will you find that? And you need to find the third largest element, right? How will you find that? So if it is not sorted, you will probably would have sorted it and then the index, get the value by the index, and you'll get the value for that, right? We, for the brute force solution, brute force way of solving this question, we can actually apply the same technique. Okay, you have the array, you basically create a in-memory one-dimensional array for that, and just left to right traversing and inserting into another one-dimensional array and sort it. Once you sort it, you want to find the kth smallest element. You just, because the index starts 0, you do the k minus 1 and you'll get the answer, right? The 9 will be the answer. So this is a brute force way of solving the question. As I was mentioning earlier, think about two techniques: sorting and memory heaps, right? uh, so let's see the solution, right? So we have taken a one-dimensional array, iterating over my matrix, two-dimensional matrix, adding every element of the matrix into my one-dimensional array, sorting it and getting the k minus 1th element, right? The acceptable solution, but we want to do it better. Heaps, right? As I was mentioning, that think of two techniques whenever you need to find the kth element uh, in a kth element in a matrix, in an array. Think of these two techniques: sorting and heaps, right? Now let's think of a different solution which is based on a different second technique, which is heap, and this technique is based on the max heap. Okay, now let's take a look at the second solution, which is based off a technique called max heap. Okay, so what we're gonna do here is, let's look at a second solution which is based on the technique of max heap. So here you are seeing that we will insert the each and every element to this max heap. We'll iterate from here, insert 1. When we'll insert 5, since it's max heap, it will keep the max element into top of the array. Then we'll insert 9, we'll insert 2, we'll insert 11. Okay, so as soon as the heap the size of the heap is equals to the kth value, what you will do, you will start removing, whenever you are adding the next element, you will remove it. So you will add 13, so 13 will go in its correct position, and once you add that element, you will remove the top of the heap. Okay, you'll remove that. Now you will add 4 to the heap. 4 will go to the correct position, right? And top of, you will be removing the top of the heap. Okay, now you will be adding 13, and now you will be removing the top of the heap. It will be there in the top, and then you will remove it. So the element which is there in the top will be your answer. The solution is basically inspired by max heap. Let's see the code of it. So we have this matrix which is given to us. We have created a max heap. By default in Java, the implementation is by min heap. This is a quick way of creating a max heap. Now what we are doing, we are just iterating over this matrix from 0 to row 0 to column, and adding each and every element to my heap. And if my heap size is becoming more than the k element, I'm starting removing the top element from the heap, and I'll keep on doing till I traverse all the elements. Once, as we see in the last example, when this traversing will be completed, I will be having the kth smallest element on the top of my heap, and that will be my solution. Right? We can just run it, see if it is working. Yeah. Okay, so that was our second solution, which is inspired by the max heap. Let's look at the third solution. Okay, this is actually, to be frank with you, this is a little tricky to come up with a solution completely in the interview. But if something you have seen some question like this, it will be easy. So forget about the question. Think of that you are given a two list one and list two, and now you want to find the third largest element in this two list. It will be 5, right? But how will you find it programmatically, right? So a quick technique to solve this kind of question is, like, say you have two pointers, p pointer here and q pointer here, and wherever you have the smallest element, you will increment that. So p pointer is pointing to 1, q pointer is pointing to 2, and this p is pointing to a smaller element, you will increment it here, and you will decrement the value of k. So by that way you will find that the third smallest element I have in this list is 5. We'll apply the same technique to solve it, but here this could be n by n matrix which is given to us. We don't know how many pointers we have to take, and that's where heap can came to a rescue, right? So what we will do, the inspiration here is, what we will do, will basically create a data structure. We will keep all the first element, okay, all the first element of each and every row. Okay, so initially we will be having 1 2 4. We are solving the same example by the three techniques and seeing how we can actually achieve to the answer, right? And here the k value is equals to, at this point the k value is 5. So what we did, we got a data structure where we stored all the first value of each and every row stored, and we just tracking the value of k now. Okay, this solution is inspired by min heap. So now, since it is inspired by min heap, so we'll be having 1 at the top of the heap. You take this element, remove this element, and get the next element which is there in the matrix, right, in the column wise. So it is 5. Since it is min heap, 5 will go in its correct position. So we have removed 1, we got 4, and 5 will go into its correct position, and here k was equals to, now we'll decrement the value of k. Okay, now you take 2, you remove 2, take the next element which is there in the matrix, next column, it is 11. So since 11 is a bigger number, it will go into its correct position, and right, again follow the same process. 4 will be removed, 13 will be introduced. So 5 will be removed and 9 will be introduced. as soon as your value reach to 1, you whatever you have in the top of the heap is your solution, right? Let's look at the solution. So yeah, let's look at the solution. Here I have created a data structure. uh, okay, in every programming language you can code it in a different way. So I have created a min heap here. Okay, and what I'm doing here is getting the first element of each and every row. Okay, I have created a custom heap here, a object where I can, in each and every reference, I can store row, column, and value, so that uh, when we are here, how do I will find that what is the next value on its column, right? So I need to, from here I need to find this value. If this is there, I need to find this value. So to do that, I am basically taking a custom heap, creating custom object which is storing three values: value and row and column, what is the coordinates of that and what is the actual value. Okay, and storing each and every element of the row, storing it to my heap, and decrementing my kth value till or it became 1. And I'm seeing, do I have something in the next, do I have a next column, right? If I have the next column, I'm adding this value. Okay, I'm adding this value into the heap. And once this solution is once this k value reach to 1, I, in the top of the heap, I will be having the value that I'm expecting. And that's the solution for this. Let's see if it is running. Yeah, I have provided all the three solutions here and explained them a little bit about that, how it is working and all. If anybody is interested in writing and seeing the code, feel free to reach out to this link. I'll be posting this in the description section. Thank you so much. Please do like the video if you learn something new from this.